Alright, so I'm going to do a visual verification. Let's see if I can get this right. And as you know, I'm right here, Blue House. I explained this is from the prior video that's on my channel. I took 42 spaces, made them all square, basically square. Damn it. I don't know why it's not all showing up. That's a good question. Are they all like that? What the fuck happened? No, this one worked. Alright, anyways, you'll just have to look at this. So, I took... Hold on, I'm going to pause it and see if I got that image. Alright, this is pi. So it goes 3.14159. As you can see, that's the numerical value. I'm going to go ahead and pause it and go back to my sheet. Alright, so this is counting... Hold on. This is counting like the first 9. This is just the 9. So you count from the top. You can see in the first column on the very left is at the 5th space, and then I counted each additional space after that. So and then the next one happened 7 later. So you got 5 more in the first column, and then 1, 2 added on to 5 is 7. So that's how we got those numbers. I had already explained this in the prior video, but in case you haven't seen that, I'm doing that now. So what I did was take these two numbers and then counted the spaces in between those. So that would be 2. So then row 4 right here would combine the 5 and the 7 to be a 2. Alright, and the 9 has the most numbers in the first 100 characters of pi, decimals, sorry. And it ends on a 9, so this is key. It gives you your maximum threshold of both in the first 100 and the diagram here. So if you decide to add advanced logic, such as adding and subtracting, adding's pretty simple. You just add it, and then this chart won't work because you'll get past the 100 marker. And since you're adding the 4 twice, it's basically doubled. You'll get like a different number, which I think would correlate. But when you do subtraction, you would have to go either completely left to right, right to left, or just take the 2 characters and then subtract the larger number or the smaller number, and it would just be too many variations. So I just avoided that. It just seemed too complicated. I think eventually it'll get done, but I'm not doing it today. So as you can see, I worked it out. So 7, there's 5 steps between 7 and 2. 7 and 2, and then 2 and 5, there's 3, etc. So then what you notice when you get down is that you see a pattern emerge. And you're like, well, how's that going to work out? First and foremost, I illustrated that pi. God, that rang my earlobe. The alphabet is in a vertical matrix. Let me pause it and I'll get that so you can see it. Damn it, my water's going wrong. Okay. Alright, I'm just going to do... I couldn't find what I wanted to find, but it's fairly simple. We're going to start at the bottom here. So, I just explained how I got these bottom numbers, but you're like, well, how do we know that 3, 3, how do we know that the underlying architecture that calculated this or created this, or whatever you want to define it as, understands the complications of mathematics? Well, there's 3 zeros, 1, 2, 3, and then it goes 3, 3, 3. Now, I know that binary is connected to this, and so is ASCII, and so does every other programmer in the fucking world that's got it this far. So, anyways, 111 an ASCII is 7. So if I remember correctly, and then 1 0 is 2. So we're just, since we don't know what characters are, well, technically we're flipping back and forth right now to try to make sure that we understand. So 1 0, so in the 22nd row, 1 0 is 2. Then we go to the next 2. 1 0 is 2. So that's knowing that this is the 22nd row. All right. Then we go up to 20. We got 1 0 0 is at 4, and then 3. To get 12 that we need to focus on before we understand what's going on. So just to make sure, let me pull that up. So we got 1 0 0, and then 1 1, and then we'll throw the 1 in there so you know that. So I will go back to the key. So we got in row 20, it's 1 right there, 0 0 times that, so it's 12. All right, but as you can see, we got a repeating pattern right there. We've got 3, understanding it's 3, and then right above that we've got 3 more, so we've got a full understanding that those 3 are back to 0, because the opposite of that would be 1. So that's where I got that jumped in logic. So at the 24, and then this is the 18th, so that's 1 0 0 0 1 0. So that's 2 times 16. Let's go ahead and look that up. That way we have no errors. 1, so that's 8, and then 0 is 2. Or is it 1? Yeah, so it's 2. So we're focusing on 16 now. So at 16, it changes. We've got 1 and then 0. So if we followed the 0 logic, all these 4s would be 0s. But this is letting you know that it understands it. 4 plus 4 plus 4 plus 4 is 16. Okay? Now if they were 0s, let's go ahead and type that in. Alright? Now, what I'm trying to explain to you is, there's 4. Alright, that's 16. Alright? And then we go, right after that, it's 1, 1. So 16 times 2 is 32. But that doesn't really work out. That brings you back to column 3 of, I'm not sure if I got that. Yeah. Column 3, row 2 is 0. So that's one of the major steps. So, anyways, you go up 1 more, and then it changes. So that's 1 0 is either 2 times 4 times 4, or is it 4 plus 4 equals times 2 is 16. Now that's forced, but since we've been doing binary, so that's 2. Oh, that could be 10. So that's understanding that the maximum threshold is 10. And U, for U, AA, so we've got 14 right there is what that's an identifier is. So it understands that it's 14. 4, 1, 2. Alright, so as you can see, they're right there. It carries out. But we're back to 24. So what I noticed is that the snake starts happening here. So it's 1, 2, 2, 1. Alright. So then technically, so that goes to U, O, C, that's coal, isn't it? 3, so 51 is 3, that's ASCII. 15 is O, and 21 is U. Coal. And then that would be back down to the end, count, and then you don't have an 84 there. Well, I don't know how to work that. So there's 40, which is 8 times 5. Anyways, I'm not getting into it. My brain's branching off again. 137. So we got 12, 12, 12. So 12 carried. So in my personal opinion, that's why those two are 0 at 628. Alright, so we got that. So it's 628. So at this point, we're jumping 216. I'm not doing all these. So I'll pause it and get online. So I'm going to search it. So we're at 624. And as you can see, I'm going to hit next. And then that only jumped a few spaces. So 628 is actually a 3. It's EGG. It's 577. And then you've got in between two eggs is 13427. So that's right there. Right there. Alright, so but the 3 is the 128 decimal. So, and then if you hit egg again, it repeats. You can see it, it's 818. But that's describing how to draw the letter. And it's one continual line, 4 dots, 4 cornered dots. And that's the 14th letter of the alphabet. So, alright, so we're at 12. U-C-O-N. I don't see that. What's 40 minus 12? Is that it? So you bring it down to 30, it'd be 28. So that's back to 28. It's identifying. So it's 40. 40 minus 12 is 28. And that ends on 28. So as you're working through this, your brain's automatically processing this. Now you may not instantaneously pick it up, but it's there. 10 is 1. Alright, so that's 321 if you see that. It's MU or and 61 equals U. So that literally it's U equal U. 1 is 37, 1 is 13. Understand that one? Alright, so 1 is, if I subtract the outer 2, 24, and that's the bottom sum total right there. So I took 13 from that. So 1, 3. So L-O. I see what we're doing. A-J-A-M. So I don't know how to do that. And then we got 1, 3, 4. We need 2, 7. And then that would be 1, 2, and then 7. So that's a key. This one right here needs further investigation. Why is that? So 16 times 2 times 7, so it's 21. I'm just going vertical right there. I'm jumping every other row. 16 times 7. Backspace 3 is 48. So that'd be count times 7. 336. Which, okay, re-looking at that. So we got that 7, and if we jump 2, like we did 1, 2, and then that brings us right back to this. How many? Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then 10 would bring that back up to here. So that 1, 4 is indicating 10 threes. On row 14, it's 40 minus 12 is 38. 28, which brings us back down to here. So let's look at that. So that's 6 plus 3 is 9. Okay. And then we got this outlier, which is 10. Okay. We got that. That's all encompassing. Oh, we got this other outlier. That's 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this would indicate 11 there for that, for the zeros. So, and then row 14 would be right here is 10 for the threes. So there's 1, 2, 3. We're going to go ahead and indicate that as 1, 2, 3. We're going to go back to here, and then we're going to do 1 is 7. We're going to count from the bottom to see where that takes us. 1, 2, 3, 4, 5, 6, 7, 8. So 7 is right there. Brings it down to 3. Hey, all right, Paul. All right, but you get it. You can just, yeah, from there it branches off. All right, I'll talk to you later. Bye.